Just as we have some special rules for exponents, and like when the bases are the same and you're multiplying, you add the exponents. If the bases are the same and you're dividing, you subtract the exponents. We also have some special rules for logarithms, and we did cover these in Algebra 2, so this is a review. So if you, for example, we've got these formulas. So log, this is for the multiplication one. So if you have log of a product, A times B, then you can rewrite this as a sum of the two logarithms for each of those factors. If you have the log of a quotient, then you can rewrite this as a subtraction problem. So notice the similarity between our exponent rules. The exponent rules involved multiplying and addition both. For that one, when the bases were the same, you added the exponents. The division rule for exponents also involved subtraction. So there is that similarity there. Then the next rule we have here, if you have log of a number raised to a power, you can actually multiply the power by the logarithm. And so it's kind of like bringing down that power in front and multiplying it. And this is called the change of base rule. And this used to be even more important before our calculators could evaluate with logs in any base. And I'm going to show you how your calculator can do the log in any base. But sometimes this is handy to know that change of base formula. So how you would use those. In order to evaluate, or for this one, whoops, didn't mean to do that. So what you're gonna do is we're just looking, we just want to rewrite them. So you're gonna find a value for the following expression. So find the rule that matches this. Okay, and if you look at rule number 1, you have in addition form. So that means I can rewrite this as log, and I'm going to multiply 25 times 4 is 100. And the reason I'd want to do that is because I can evaluate this. There's no base, log base written. That means it's understood to be log base 10. So this is 10 raised to what power is 100? And the answer would be 2. On the next one, again, we have, because they're the same log base, they have to be the same log base in order to use these rules. So it's addition. So I come up here and I'm going to multiply and follow this rule. So if you multiply 3 halves times 32 over 3, let's just kind of take a look at that. So 3 halves times 32 thirds. The 3's cancel. And here I have, or cancel the 1, and here I have a 1, and here I have a 16. So this becomes log base 2 of 16. Now I can think of this as 2 raised to what power is 16? Well, 2 to the 4th power is 16, so that's my answer. On the next one, this is subtraction, so it's going to be rule number 2. So here it's in this form. I want to switch it to this form. So I write this as log base 2 of 40 divided by 5. So it's log base 2 of 8. So this says 2 raised to what power is 8? So the answer would be 3. Next one, same rule. It's subtraction. So I'm going to use the division. So I get log base 5 of 100 divided by 4. So that's log base 5 of 25. If I rewrite this in exponential form, 5 raised to what power is 25? And my answer is 2. On the next one, actually on this one, I think the intent is to use rule number 3, which we could. But you also could think of this as log base 10 of 10 raised to a power. So we already know that those are going to cancel each other out, and because it's an inverse operation, and just leave the 35. But you can also rewrite this as 35 times log of 10. Now log of 10 is just equal to 1, and you can, 10 raised to what power is 10? The first power. So you get 35 anyway, so 35 times 1. So that does illustrate how you can use this, the power rule. Okay, on this one, we're going to bring the 5 down. So I have 5 times log base 2, and then let's think of this as 2 to the 1/2 when we do that. So 2 raised to 2 to the, well, these are just going to cancel out. Log base 2 of 2 is just going to give us the half. So we're going to get 5 times a half, which is 5 halves. Okay? Now, on this next one, because this is addition, you actually, this works for more than two factors. So here we can have log of 50 times 4 times 5. So we get log of 1,000. 10 raised to what power is 1,000? 3. And that would be your answer. On this next one, we're going to have log, it's going to be base a third, and we have subtraction, so we're going to use division. So we have 4/3 divided by 12. Okay, so to do 4/3 divided by 12, remember when you divide by a fraction, it's the same as multiplying by the reciprocal. So I get 1/9, so this is log base a third of 1/9. So I'm going to rewrite this in exponential form. 1/3 raised to what power is 1/9. And you can do this with a common base. Think of this as 3 to the minus 1. So that'd be 3 to the minus x equals 3 to the minus 2 when you find a common base. So x would have to be 2. To illustrate the change of base formula, which was the 4th one on that list, if you need to evaluate log base 4 of 20, you can actually change them both to common log. And if you just evaluate log 20 over log 4, now you wouldn't know these because there's no way to know these without the use of a calculator. So at this point, you would take a calculator and you could evaluate, move this out of the way a little bit. So we could evaluate log 20 divided by log 4 and come up with a decimal approximation. So, whoops, there goes that calculator. Oh. Okay, let's... Okay, now I don't think it will disappear on me. So we get approximately 2.161. Now, I want to show you something on your calculator that you can also do. If you were, with kind of the newer versions of these calculators, if you were to look at, oh, it was this one, where it says log base, so it's second and then the F2 button or the window key. And if you actually input this with log base, okay, it would help if it did the right one. Try that again. Okay, so number 5. Well, this is not cooperating here for me. Okay, so let me quit this and start this over again. All right, so number 5. And notice that we get this little symbol here. So we want log base 4. So type in a 4 and then the arrow key and put in a 20. And there's the same answer. So the change of base formula is not as critical as it used to be with what we can now do. It used to be that the only way to get these answers was to use the change of base formula for logarithms. And when we're in class, I'll have to show you my book of common logs, because it used to be that you would just learn some of the common log values. You'd memorize them. You'd have a table, and then to evaluate other log bases, you'd have to look those up and actually do the math. So you guys should really appreciate what your calculators can do. So these are pretty simple. Then you could go ahead and finish these up on your own.